we will get it rendered and posted. The downside of doing it this way is that unless you all exit, the recording doesn't stop. So I want, like, you got to, when we say the meeting's over, you got to exit the meeting so we don't have 5 hours of your screen. So you have to
leave
and exit. We want 5 hours of Miss Rondeau.
That's right.
Okay, so we're going to pick up where we left off. We left off on page 249. I'm going to start us off here a little bit today. And
247.
We were really 247?
Yeah, I think you're looking at an old version.
I know I'm using the 1920 version, and I don't know why I'm off by like 2 pages. So apparently it's page 247 that we are starting on. I don't know what's wrong with my version. All right, so I'm going to, so when I write, I'm going to flip my screen for a minute, so you're going to see my ceiling and not my face. I apologize for that, because I'm going to use a slightly different app, but I know my calculus kids are enjoying this a little bit better. So we should be right here. We're talking about trigonometric values for special angles. I'm sorry, it will flip the right way, and there we go. If you've got questions or concerns, either come off your microphone and tell us, or put it in the chat. Miss Rondeau is watching the chat for us. We're going to talk about special right triangles, and you have all seen these probably before in geometry. Okay. So all I'm going to do is set up the ratios on these triangles based on the sine and the cosine and the tangent that we learned yesterday, and then Miss Rondeau is going to take over and talk. I'm assuming, are you putting the formulas in there, Miss Rondeau?
Yes.
Okay, so, as I always teach it with the formulas, we didn't discuss that ahead of time. So we're going to, so all I'm doing is the ratios based on what we did yesterday. All right, so I'm going to come at this from the approach of sine, cosine, and tangent. Okay, so I'm going to start with my 30 degrees, which would be this triangle right here. Okay, and I'm going to do all of my 30 degrees and pick out what's missing. So according to this 30 degrees, this leg would be my opposite. This one, Andy, this would be my hypotenuse, and this would be my adjacent. So for tangent, I know I need opposite over adjacent. And you can see how much I'm abbreviating, which means I need 1 over square root of 3. Now, we don't like that radical in the denominator, so I'm going to multiply top and bottom by square root of 3. So we'd really have square root of 3. And then we learned yesterday that a radical times itself in the denominator is just the number underneath. So it's just a square root of 3. So we would write it as 3 square root of 3. I'm going to go down here to the 30 degrees there. Now, I could look at cotangent 2 different ways. I could either do adjacent over opposite, okay, which if I did adjacent over opposite, I'd have square root of 3 over 1. Or I could come back up here to where before we did the flip and just flip, or before we did the rationalization and just flip that, and you'll notice they're the exact same thing. Okay. All right, I'm going to do another angle now. I'm going to erase I'm going to do 60 degrees next. I'm going to erase what's on that triangle there. Okay, but I'm going to use a different color. So here is 60 degrees. So that's my reference angle. This time it says that I need sine. So I'm going to label that this is opposite. That across from the 90 is my hypotenuse. And that next to my 60 is my adjacent. So for sine, I know I need opposite over hypotenuse. If it helps you, write out SOHCAHTOA. Okay. And then show, sha, cow, if that helps you. And you can, or am I writing a Q? And if that helps you identify. So I could just go to sine. I know it's opposite over hypotenuse. All right. So my opposite is square root of 3. And my hypotenuse is 2. And then when I come down here to the cosecant of 60, okay, we are going to just either flip the reciprocal, or I'm going to write the hypotenuse over the opposite. So when I do that, I get 2 over square root of 3, which means I am going to have to rationalize. So square root of 3 over square root of 3, which means I've got 2 square root of 3, and then radical 3 times itself is just a 3. And I apologize for squishing it in there. All right, then I am going to look at 45. On this one, there's 2 45-degree angles. It does not matter what you pick for your reference, so choose one. And I'm going to label again, across from my 45 is my opposite. Across from my 90 is my hypotenuse, and next to my 45 is the adjacent. It's tough to mess this one up. This time they're asking me for cosine. So I know that cosine is ca. So cosine is the adjacent over the hypotenuse. So my adjacent is 1. My hypotenuse is square root of 2. I'm going to rationalize. We're going to rationalize so much in the next month that it's going to be insane. So you're going to have those memorized. You're just going to know that 1 over square root of 2 is square root of 2 over 2. And then this one here, secant 45, is going to be the hypotenuse over the adjacent. So my hypotenuse is 1, and my, sorry, square root of 2. And my adjacent is 1. I could just write that as square root of 2, and that would be fine. Just like there was another one. I could have written this one as just square root of 3. All right. And I think from there, that's where you're going to take over, Mrs. Rondeau, right?
Yes, it is. All right.
I'm going to go back. I don't know if I have to release my screen or not, but I'm going to end my presentation and let you take over. And I will watch the chat.
Okay. So we're going to see if I can do it quickly. All right. Okay, so you guys just looked at 30, 60, 90 triangles using sine, cosine, and tangent. So what I'm going to do with us is we're going to talk about the 3 bears. And this is going to be a first for Miss Ballard. So those of you who know, now Miss Ballard will be in the know as well. So 30, 60, 90. I call this the 3 bears triangle. For those of you who are not familiar with Goldilocks and the 3 bears, it's a little kid's story about a little girl who goes into a house that belongs to 3 bears, Papa Bear, Mama Bear, and Baby Bear. And if you can't, I'm not going to tell the story, that part of the story, but if you can imagine, if there is Papa Bear, Mama Bear, and Baby Bear, you have probably 3 different sized bears, Papa Bear being the largest, Mama Bear being a little not quite as big as Papa Bear, and then Baby Bear is the smallest. So we're going to use that to help us with this triangle, refresh the relationships we have in our triangle. So in a 30, 60, 90 triangle, first of all, I'm going to label my angles because this, oh dear, my pen's not being happy. Just a second. Come on, honey. You can do it. Okay, so I'm going to label my angles. I mean, this one would be our 60-degree angle, and up here is going to be our 30-degree angle. By the way, this particular picture, the screen is not in your notebook. You can add it, or you have the triangles you guys just did a second ago. It's up to you.
This would be great to put in the left-hand column as an annotation.
Yeah, that's what I would do, is just add it kind of on the side, because you will want to know these relationships. They're super important when we move into trig. All right, so here's my 30, 60, 90 triangle. If you remember from geometry, the shortest side of a triangle is across from the shortest angle. The largest side of a triangle is across from the largest angle, and they all match up. So in this triangle, the shortest side is going to be across from the 30, which I'm going to call X. And that is going to represent Baby Bear. As I talked about a minute ago, the 3 bears, we have Papa Bear, Mama Bear, and Baby Bear. Baby Bear is the smallest. And for anyone who knows, anyone that's had a baby in the family, everything is all about the baby. No one cares about anything else. All they want to see is the baby. So the world of the 3 bears all revolves around Baby Bear. We always start with Baby Bear. That's like the most important one. Not most important, but that's the one we focus on. Everything builds from Baby Bear. So then we're going to go from Baby Bear. We're going to take a look at Papa Bear. Papa Bear is twice as big as Baby Bear. So we represent that with 2x. Or we say to go from the short side, short leg, to the hypotenuse, we multiply by 2. So Papa Bear is twice as big as Baby Bear, always. And we can do that relationship in reverse as well. For example, if I know Papa Bear is 16, that's the length of Papa Bear. If Papa Bear is 16, how much would Baby Bear be?
Put it in the chat.
Yeah, put it in the chat.
How big is Baby Bear if Papa Bear is 16? All right, we're getting a lot of 8s in the chat, Mrs. Rondeau.
Woohoo! Yes, so Baby Bear would be 8 because Papa Bear is twice as big. So when you are given a 30, 60, 90 triangle and they tell you, come on, Pen, they tell you the hypotenuse, if that's the number they give you, you can always go in reverse and you would divide by 2 to get back to baby bear. So that relationship is true for all 30, 60, 90 triangles going from the short leg to the hypotenuse or back. Then we have, so that's Papa Bear and Baby Bear. Then we have Mama Bear. Oh, Mama Bear. She loves her family. Mama Bear works super hard to take care of, as you guys probably know, most moms work super hard to take care of their family and take care of the whole group. So Mama Bear, she loves Baby Bear, and she works in the house and takes care of all 3 of them. So Mama Bear is worried about her whole family, which is why we have three different sides. Mama Bear works in the house to take care of all 3. So the house I use as my square root, and the 3 to represent her love for her whole family. But Baby Bear, of course, being the focus there. So Mama Bear takes care of all 3. That's a little phrase that you'll hear me say. Mama Bear takes care of all 3. So to do that, mathematically, we take whatever Baby Bear is, because it's all about Baby Bear. And to get to Mama Bear, we would be multiplying by the square root of 3. And then, of course, vice versa. If we are given Mama Bear, we can work our way backwards by dividing by the square root of 3. So this relationship where we multiply by a number or divide by a number to move back and forth, that's going to be super handy if you know those general side lengths. Papa Bear, twice as big as Baby Bear. Mama Bear takes care of all 3. It's a nice little catchphrase there. Any questions? How are we doing, Miss Ballard?
We're doing good. I like it.
All right. Then our next one, and this one is also not in your notebook, but you can just tag it on the side there. Draw yourself a 45, 45, 90 triangle. And I'm going to just label my angles 45. It's less important in this one since they're both 45 degrees, but we're still going to label them. 45, 45, 90. This one, for those of you who remember, or those who don't, new for us. This one I call the Zach and Cody triangle from The Sweet Life of Zach and Cody, because they're twinsies. So with the 45, 45, 90 triangle, you have one of the twins. Come on, pen. My pen's being a little bit slow today. I don't know why it's being funny. Okay, so one of the twins, if I call this first one Zach, if I say he is 8 years old, how old is Cody? He would also be 8. I don't need you guys to type that in the chat. That's the same number. Whoops. Okay, so however much Zach is, Cody is the same. They're twinsies. They're the same age. They matchy. Then those I call the twin side, Zach and Cody. Then to get to the hypotenuse for this triangle, the hypotenuse, I say Zach and Cody are whatever age they are, and there's 2 of them in the same house. Now, of course, that's probably not true anymore since they've grown up, but before it was 2 twinsies in the same house, so square root of 2. And that mathematical operation, of course, is multiply by square root of 2. And if we want to go backwards, if we're given what I call the house side, the hypotenuse, come on, pen. There we go. Then to go backwards, we would divide by the square root of 2. So that kind of gives you that relationship. So these relationships, again, are going to be used all over the place. So when you see an isosceles right triangle, if you know one leg, you know the other leg has to match. And then the hypotenuse, you just multiply by the square root of 2. All right, so that's, any questions before I go on?
Does not appear so.
Okay, then let's move forward. And this is back in your notebook examples. It should be, hopefully it's example 13. Looks like it is. All right, we're going to practice those relationships. So we have a 30, 60, 90 triangle. I didn't ask this question, but I am going to ask and see how many awesome geometry students we have. How do I know that angle is 60 degrees?
So put it in the chat. How do you know that angle is 60 degrees?
Because Miss Rondeau said.
No.
No? Oh. Dang it.
Oh, we got some super smart students here. They're all saying that the triangle adds up to 180 degrees.
That's perfect. Yes, exactly. Triangle sum theorem says all the angles in a triangle add up to 180 degrees. So if we did the math and did the 90 degree angle plus the 30 degrees, We could subtract that from 180. There's also another shortcut theorem that says the two acute angles in a right triangle have to add up to 90 because the 90-degree plus the other two angles together as 90 makes 180. Anyways, nice little review from geometry. Okay, so we have the side that's given to us right here. This is our hypotenuse, or excuse me, from my story, this is Papa Bear. So if Papa Bear is 8, we always want to go, whatever they give us, on a 30, 60, 90, we always want to go back to Baby Bear. So they gave us Papa Bear. What would Baby Bear be? Go ahead and type it in the chat.
I'm seeing a lot of 4s, Mrs. Rondeau.
4. Okay, so then I would put in 4. So x equals 4?
They just said 4.
No, they're right. They're right. Baby Bear is 4. I am now suggesting that x is 4. Am I right?
Oh. Is x equal to 4? Oh, let's see. Oh, they're saying that it's not. I wonder why.
What? I never make mistakes. That's crazy. No. They are correct. X is not 4. The side that I actually found was Baby Bear, which is over here across from the 30. That's the short side. So be careful that you don't just go to, going to Baby Bear and say, oh, it's 4, because I know that's Baby Bear. We are actually trying to find, sorry, my pen is being super delayed today. Yesterday,
Ariana is saying that X is Mama Bear.
X is Mama Bear. That's correct. And actually, since I'm waiting on my pen anyways, if anyone wants to try to type in what the answer is for X, that would be fabulous, since my pen is just not, oh, there we go. It finally decided to agree. Kind of hard to type that answer in because it's going to have a square root with it. Not that I'm giving it away. Did we get any takers on the answer?
No, we have not. Oh, wait, 1. Fallon says 4 times square root of 3.
Awesome. That's perfect. Thank you, Fallon. Thank you guys for getting through that one. I'm going to go a little bit faster through some of the remaining ones, but there's the basic concept. You multiply by the square root of 3. And what do you know? It's like the norm for my pen to be crazy. I don't know how yours is, Miss Ballard, but from my tablet, my pen sometimes is a little.
That's why I give it up on that.
All right.
The device for next year is so much better.
Very good. All right. So then we're going to find X and Y. So this one is a 45, 45, 90. You could fill in the missing one if you want, based on triangle sum. This time they gave us the hypotenuse, which is right here, which on this particular triangle, this would be our Zach and Cody. I call that the house side. So to go backwards from the house side to one of the twins, we would be dividing by the square root of 2. So to take that 6 and divide by the square root of 2, we could report our answer that way, but Mrs. Ballard and Mrs. Rondeau would be very unhappy because it's not rationalized.
Correct.
Yeah. So we want to fix that up, multiply top and bottom by root 2. And remember, square root of 2 times square root of 2 will give us 2. Then I can simplify even one more step. 6 and 2, 6 in the numerator, 2 in the denominator will reduce to 3 square root.
Why didn't you cross out the 2s?
I did not cross out the 2s because I don't like 2s. No, actually, it's because we cannot cancel or divide or anything when we have one number in a radical and one number not in a radical. So the only time we could cross those out is if they were both in a square root.
I like to say the insides with the insides and the outsides with the outsides.
Yep. Very, very similar to what I say as well. So we are on the same page. I like it. And of course, there we go. Okay. All right. So then again, finding X and Y, we have another 45, 45, 90. This time it's going to be a smidge easier because they gave us one of the twins. This could be Zach or Cody. If Zach, I always start with Zach. I don't know why, because he's first, I guess. If Zach is 13, then we know that Cody is 13. Those sides have to match. And then to get to the house side or the hypotenuse, we multiply by the square root of 2. Awesome. I'm going to keep moving us forward.
We're doing really good on time.
Yeah, I just stop, Mrs. Ballard, stop me, or students, if you have questions, type it in the chat. Make Miss Ballard stop me. I'll just keep going. I love the 3 bears and Zach and Cody. All right, so this time I added in for my 30, 60, 90, actually, let's ask this question. Which side of the triangle did they give me? Go ahead and type that in the chat.
All right, so did they give us Mama Bear, Papa Bear, Baby Bear as the side of the triangle? Put that in the chat for us. I'm seeing a lot of Mama Bears.
It is Mama Bear. I will add too, although I say this, and this is new for Miss Ballard to talk about them as Papa Bear, Mama Bear, Baby Bear. If you really do not want to call them that, it is okay. You can call them short leg, long leg, and hypotenuse. That is how the rest of the world, the boring people, that's what they say. The exciting
I am boring.
What's that?
I apparently am boring.
Yeah, I'm sorry, Mrs. Ballard. Oh no. The truth comes out. Okay, what I say about you when you don't know. Now you hear it. Okay, I'm sorry. Let's go ahead and start then. We're going to start with Mama Bear because that's the number we were given. And we always want to go back to Baby Bear. So I'm going to go back to Baby Bear. To go backwards, I would be dividing, and I would be dividing by the square root of 3 on the 30, 60, 90 triangle. So I'm going to take 4, and I'm going to divide by the square root of 3. Again, we got to fix that up. So top and bottom, multiply by square root of 3. We get 4 root 3 over 3. And again, like Mrs. Ballard said, we're going to do this a lot. So you're going to see this rationalizing like crazy. All right, so my x then is 4 root 3 over 3. And then from Baby Bear, I'm going to go to Papa Bear. So Papa Bear is twice as big as Baby Bear. So I'm going to do twice as big as Baby Bear. So if you're not super comfortable with that, put a 1 under your 2, multiply straight across. Remember the outside numbers multiply by the outside numbers, inside by the inside. So 2 times 4 will be 8. We do not multiply the 3, it stays inside. And then on the bottom 3. So Papa Bear, or the hypotenuse, is 8 root 3 over 3. All righty, let's keep moving through. I'm going to assume that we're good unless Miss Ballard yells and screams for me to stop.
I do not have anything else in the chat, so we're good. Awesome. And I was a little distracted because I made myself a new sign. So
okay. All right. So again, a 30, 60, 90 triangle. This time they gave us the hypotenuse. So Papa Bear, and we want to go back to Baby Bear. So again, be careful about which side you go back to. Make sure it's Baby Bear. So I have 2 root 3, and I want to go back to Baby Bear. So that's going to be divide by 2. Excuse me, not funny there. Divide by 2, and I get square root of 3. Again, those 2's cancel out. Cancel to equal 1. Sorry, it really bothers me when it's messy. I mean, I know it's messy, but okay. All right, so then we know that y is the square root of 3. Then I need to go to Mama Bear. And to get to Mama Bear, I'm going to be multiplying by the square root of 3. So I have square root of 3 times square root of 3. That should be pretty familiar at this point. When I multiply matchy square roots, the answer is just the number. So x equals 3. All righty. Then we shift gears a little bit from 30, 60, 90 to go back and practice trig. So hopefully you enjoyed the 3 bears and Zach and Cody. The next 2, actually, I think I'm doing 19 and 20. We're going to skip 18 just because. And we're going to go to 19 and practice this one.
If you have your scientific calculator, or you can do kind of the split screen, or on your phone Desmos app, then I would have that in front of you right now. Sorry, we did not warn you ahead of time.
Yes, I am sorry. I will put it up on the screen though in a second. I'm going to switch out of this so we can see it. All right, so they give us some information and they ask us to solve the triangle. If you have forgotten.
We didn't stop for a joke. Well, maybe while they're getting that up, we could tell a joke.
Oh, go for it. Yes, that would be great.
Right. Andy, come here, quick. Tell a joke. Do you have one? Okay.
Coffee break.
Here's Andy. He's telling a joke. Go for it, Andy.
What you get if you divide the circumference by the diameter of a pumpkin?
What do you get if you divide the circumference by the diameter of a pumpkin? I don't know.
Pumpkin pie.
Oh, pumpkin pie. That was a good one. Thank you.
That's a good
All
one.
right,
Thank you,
let's get
Andy.
down to the- I do side. That's very fitting for mom, apparently.
It's very nice.
All right, Mrs.
Andy's
Rogers,
having a good time.
What?
I said Andy's having a good time.
Yes. Apparently, I'm going to let you keep going now.
No worries. All right. So just in case you have forgotten what it means to solve a triangle back from geometry, it means find all the missing sides and angles. So I'm going to first start by labeling what they told us, which is A is 32 degrees and B is 10. So you have some options about what to start with. Typically, I like to get rid of the angles first because I think they're easy. So we mentioned doing triangle sum, or the shortcut version is to take 90 degrees and subtract 32 to find the other missing angle. So this would give me 58, I believe. Someone to check my math. I don't add and subtract very well sometimes when I'm in a hurry, or, whatever. But I believe it's 58. All right, so that gives us our missing angle. So on these, I also like to list my answers. So they already told us A and B, so my angle B is 58 degrees. And then we already know C is 90 degrees, so then we're just finding the missing sides. Since you have both angles, you could really do either one. As for your trig functions, it's your choice. Since they gave me 32, I tend to stick with the one they gave me. So, and then you have a choice. Whoa, where are we going? There we go. All right, you have a choice as to which side you want to solve for. So I'm going to actually start with finding side A, which from 32 degrees, this is my opposite. And then I have to use a side that I already know. I can't have two unknowns. So I'm going to pick B equals 10. This is going to be my adjacent. So with those two trig functions, type it in the chat. With those two sides, what trig function should I be using?
So are we looking for sine, cosine, tangents? We could, I suppose, use cosecant, secant, and cotangent, but we don't tend to see those as much when we do this kind of solving.
Yeah, technically it could be any of the reciprocals as well.
I'm seeing a lot of tangents.
I like tangent. All right, so tangents. If I set up tangent, we're going to do tangents of 32 degrees. So remember, it's always the trig function with the angle. The trig function is based on which angle you're at. So tangent 32 equals opposite, which is my A, over adjacent, which is 10. Then from there, you have any which way you want to solve it. You can multiply both sides by 10. And that would be perfectly fine. When we did it in geometry, I tended to do cross multiplying. So I would do, put that over 1, cross multiply, and do the love connection. You guys might remember that from geometry. It drove you crazy with it. Anyways, you can do it any way you want, but you're going to end up with tangent 32 degrees equals A. Quick pause right there. Be super careful if you are multiplying. When you multiply both sides by 10, whatever method you do, the 10 does not multiply by the 32. That 32 is stuck with the tangent. It's part of that tangent function. It doesn't change when you're solving. So it's always going to say tangent 32.
Mr. Rondo, maybe it'd be helpful, put parentheses around your 32 for me, so then they can kind of see it, how it gets typed into the calculator.
Yes, ma'am. Perfect.
Thank you.
Yeah, not a problem. All right, so at that point, we're going to jump over and look at Desmos. I'm going to do it on Desmos. You can use whatever version you want, whatever calculator you have handy. There's my Desmos. All right, so I believe it was 10 times tangent, so I'm going to do 10 times, and I just use the little star key for my times. And then when I go to tangent, I believe, actually I'm typing it in. Tangent will work that way.
Yes.
And then 32, you can just type the word tangent. You can also go down here to the bottom corner of your screen where it says show keyboard. If you go over to functions, and click on that, it will also give you tangent here. So, and then it will automatically put those parentheses in for you. Either way is fine, but that's two ways you can do that. And even as I type it, it calculates it for me. I can finish it off if I want it to look pretty.
We're a little bit off of the answer, Miss Rhonda. I wonder why that is.
We're a little bit off of the answer. What do you mean?
Can you go ahead and hit that little wrench for me?
This?
Right corner, up the graph. Ah, we need our calculator switch to degrees right there for us.
There you go. I was like, what do you mean we're off our answer? I see. Yes, yes.
Just a little bit. So so Desmos automatically is in radian mode. So you have to put it in degrees, and you might have to do that on every calculation.
Yes. Should you guys on your own calculators, typically a scientific is in degrees.
Starts
usually.
in degree mode, yes.
But if you have a graphing calculator, that one might be in radians. So you need to check your settings. And depending on what graphing calculator you have, usually it's in the top right corner, very similar. But you do want it in degrees for this. We'll get to radians soon.
Yes.
So you guys can play with radians. All right, so because I just put it in radians now, I'm sorry, degrees.
Degrees.
I need to redo that calculation because it's not going to change what I already calculated.
It did change the number for us.
Oh, did it? Oh,
Yeah.
well, never mind. Then.
It was 6.1 something before. It's now 6.2.
There you go. But that is a big deal, especially when we get to doing things back and forth in radians and degrees, is to make sure your calculator is in the right mode.
Correct.
Very important. Okay, so that's how you type that in, 6.2. How many decimals do you want, Miss Ballard?
3, please.
249. Great.
249.
Awesome. Okay, so, and actually, the last time that I taught this, I didn't even make I didn't make my students put it in the calculator. I think I was in a hurry. It's like, oh, we'll do that later. We'll practice calculator later. So 6.2, was it 49?
49.
Awesome. All right, then our last one on this triangle, we need to find C. So again, you can use either angle that you want. I tend to stick with 32 because I'm boring, even though I said before I was not boring, but whatever. So I'm going to stick with 32, and I like to use, what's that?
You can have my sign.
I'm going to use the 10 because that number, so I'm going to use side B because that number is exact and it will give me a more accurate answer than using side A, so that's kind of a trick of the trade there. Use the exact number, whether you use 32 degrees or 58. So from 32 degrees, 10 is still the adjacent, and I'm looking for the hypotenuse. So now I need a trig function that will do adjacent and hypotenuse. Go ahead and type that in the chat. What are we looking at? Adjacent, hypotenuse. Which trig function is it?
All right, so in the chat, I want to see what is adjacent over hypotenuse. Oh, they're so smart. I'm seeing a lot of cosines.
I like it. I like it. All right, so cosine. Let's do cosine. Cosine of 32 degrees, and I'll even add those parentheses to help us out.
Thank you.
Yep, no problem. Equals my adjacent over hypotenuse. So this one would be a time where I would encourage you to, again, you can use any method you want. You can multiply both sides by C, solve it in any way that you see fit. I'm going to go back to good old cross multiplying, doing the love connection, because I love to irritate my students. Oh, no. Yes. Okay, so let's multiply C times cosine. So this one could be confusing, so I'm going to definitely do a multiplication symbol here. So we keep the C separate from cosine 32 degrees. You'll notice I always write whatever number I'm multiplying in the front rather than in the back, so I don't accidentally multiply by that angle. All right, then 1 times 10 gives me 10. To get C all by itself, I'm going to do the opposite of multiply and divide by cosine 32 degrees.
Why are we dividing by that? It's got letters in it.
Because well, do you want me to answer or you want them to answer?
Go ahead, Ms. Rhonda, I'll let you answer.
Because it is a function that goes together, so that cosine 32 degrees represents a ratio on a triangle. So that represents, the whole thing together represents a value.
Yeah.
A number.
It's a funny looking decimal point number. It's just cleaner to write it as cosine of 32.
Yes, rather than put it in our calculator. It's much, again, we're not trying not to round unless we have to. Round at the end. All right, so then when I do that, I'm going to cancel those out, those cancel out, and then I need to go back to my Desmos so I can do this calculation. So I'm going to switch back to Desmos. Yep. Okay, so back to Desmos. So this time I want to do, was it 10 divided by cosine 32?
Correct.
So 10 divided by, and the Desmos will do that fraction. Once you hit that divide, that slashy, it will do a fraction for you. Make sure just that you're careful with fractions, that you enter things in the right place in your fraction. So I definitely want the 32 to go with the cosine in the bottom. And
they're giving me answers in the chat.
Ooh, yay!
I
Good
know.
job.
They're on top of it today.
Just double checking.
11.792 is what they're saying they're getting. It looks like they match.
Awesome. I just double checked on my screen that I am still in radians, which it won't switch unless I closed it out and reopened it. But assuming that I had done that, I would want to make sure that it is in degrees. Okay, so 11.792. I'm going to go back and type that in, or write that in with your guys' assistance. 11.792.
Yep.
Awesome. So then, like I said, I'm kind of funny and I like to list all my answers together. So angle B we had at the top was 58. A was 6.249 and C was 11.792. Mrs. Ballard, would you maybe comment on why you asked me to do 3 decimal places?
So 3 decimal places is the standard for your AP Calculus test next year. So that's the habit. And that, I know the ones in my class know that because I harp on it all year long. So we keep 3 decimal places, but we do not do those decimal places until the very end of the problem. You will notice, I know those who have me for class, notice that in the calculators, we keep like 6 to 8 decimal places hanging out in there because we need an accurate answer at the end. So we train you guys early.
Yes. So anytime that you round, you take away some of your accuracy. So we don't want to round until the very end if we can help it. Yeah. All right. Well, there you go. Oh, no, that's only one. Ha, that's only one. I still got one more to go. I'm sorry, one more time. So we're going to practice that and hopefully a little bit faster. We'll go through that process. I might actually, Mrs. Ballard, when we get to the calculation part, or students actually.
I will let you, I have the numbers, so I can let you know your answers.
Yeah, that would be great. That way we showed Desmos, but I want to move through this. So also students, when you guys, if you want to run through it, you know, you've got it, go for it. You can type those answers in as I present them. That'd be great. Okay, so once again, I'm going to label this as 71 degrees. Then I'm going to go to C. This time we're given the hypotenuse as 20. And again, I typically like to start with the angle. And so I'm going to do 90 minus 71, and that's going to give me 19. So my missing angle is 19 degrees, and I'm going to make my list over here. B is 19 degrees. Great. And then I'm going to go through and start picking a trig function. You can do A or B first. I'm going to just start with A, which is my opposite side. So I have opposite and I have hypotenuse. So I'm going to, like I said, I'm going to go a little faster on this one. This would be sine of 71 degrees equals A over 20. To solve that, I did a lot of cross multiplying last time. This time I'm going to do just a more traditional solve. I'm going to multiply by 20 on both sides. And fill in those parentheses. All right, so I have 20 sine 71 degrees is going to equal my A. And do we have any students that have typed the answer to that in the chat? We'll give you a couple seconds to do that.
Nobody's that fast yet. Let's see if any of them have done it.
Well, I am pretty fast, so.
Oh, here we go. Dima says 18.910.
18.910. Can I get a verify? Thank you, Dima, for that answer.
Is there anybody else who got that same answer? Oh, Pearl says, yup.
Pearl says, yeah, but verify. All right. That's kind of my routine in the classroom. I let the students do
Casey matched it,
calculations.
and so did Casey and Stephanie also matched it. So we're good.
I asked for verification. If several people get it, we're good to go. Awesome. All right, let's move on to the last thing we're going to solve for in this triangle. That is B. And if like I said before, I'm pretty boring, so I'm going to stick with 71 degrees. My B is going to be my adjacent side. And because I want to use as exact an answer as possible, I'm going to still stick with using my hypotenuse of 20. So now I'm doing adjacent and hypotenuse. I'm going to use cosine. So cosine of 71 degrees is going to equal adjacent, which is my unknown, B, over 20. And again, doing that quick, not cross multiplying, just quick solving, multiply both sides by 20. And so I get 20 cosine 71 degrees equals B. And help me out, what is B?
All right, does anybody have it? Did anybody get it? Put it in the chat real quick if you got it. Dima is saying she's quick, 6.511, and I got Ariana and Jocelyn also saying the same thing. So we've got Casey, and Stephanie is indicating that she got it. So we're good, I think.
Awesome. All right. So then, of course, my lameness going back to answer the question. Well, it's not lame to answer the question, but I like to list it all in one spot. So here's my answer that I'm going to report back to Mrs. Ballard. Mrs. Ballard, I got the answer.
Awesome.
Okay. Awesome.
Great job.
Yes. And I'm going to hand that back to Mrs. Ballard. We have one more section for you guys to go through. Yeah. So there you go.
All right. I'm going to go ahead and share and take over here. So I am, okay. So I am now presenting and you should be seeing me. I'm going to go back here. I get to go and I get to do angle of elevation and angle of depression. So I'm going to, I know this is tough. It's a rough section. So I'm going to give you like 1 minute. We're not going to talk. We'll just sit in silence. I will go get the next child to do the joke, but while you're waiting for us, you can go ahead and write those two definitions down. Hey, Ellie, you want to tell your joke? Keep going. Okay. All right, come on over here, Andy. Quick. All right. Andy is going to tell the joke because Ellie is actually in class right now with math. So, all right, tell it quick.
Did you hear about the mathematician who didn't like negative numbers?
I did not hear about the mathematician who did not like negative numbers.
He'll stop at nothing
He'll
to avoid them.
Oh, he'll stop at nothing to avoid them. That was a good one. All right.
That was a good one.
I'm flipping my screen so you guys will probably see my ceiling and hopefully not up my nose. So angle of elevation, now that you've gotten a chance to write that down, is the angle by which an observer's line of sight must be elevated from the horizontal to a point. So angle of elevation, notice and it kind of goes back to parallel lines from geometry. It's when you're from a horizontal line and you're going up. I like to think of it as when you're happy, you're elevated, you are going up. Or an elevator, typically you're at the bottom floor and it goes up. Angle of depression is the angle by which an observer's line of sight must be depressed from the horizontal to the point observed. So it's a horizontal, okay, down to a point. A common mistake is people will put it, this is the bad spot, it does not go in there. That's a no-no, okay? It's not the one next to the inside of the triangle.
Big no-no.
So, what was that?
I said big no-no.
Big no-no. So when I think of angle of depression as when you're depressed, oops, I don't have my pen going. You're sad, so sad angle, it's depressed, so it's the one that's going down. But the kind of cool part about this, if you remember from geometry, alternate interior angles. All right. I don't get to teach a lot of geometry nowadays, but alternate interior angles, we know that those two angles are congruent. So that means my angle of depression is also my angle of elevation. So as long as I get one, what I typically do with my depression is I will replace it down here in my angle of elevation. And you hopefully are seeing, we're going to try to create right triangles there. All right, let's do a couple of these. On the exciting part, you get to see me draw pictures. So that should make for an exciting.
Now
All
Mrs.
right.
Howard understands why she's doing this part, so you don't have to see my pictures.
Apparently, I'm boring, but I'm the better artist, apparently. Okay. All right, so a parasailer is attached to a boat. Okay, so we need a boat. Here comes the boat. I'm super artist. And we need a parasailer. And he needs his little parasail. There we go. Okay. Oh, he's got to be attached to the boat. So there he is attached to the boat. They attached to a boat with a rope 300 feet long. I'm going to go ahead and label that right on the rope. The angle of elevation from the boat to the parasailer is 48 degrees. So I need to have a horizontal. Because I attached him at that little corner of the boat, I'm going to draw it from there, not from the bottom of the boat, because my goal is to create a right triangle. We are supposed to find this height right here. So you hopefully can see how I have created that right triangle. And then we are supposed to estimate the height above the boat. So I am looking, oh, I know that this is 48 degrees. I missed that part. So that was the angle of elevation up. So I know that it goes in that bottom left corner of the triangle. So I'm just going to look and see what I have and what I can, and which trig ratio that I have. So I'm not going to solve for everything. I believe the homework problems in Desmo or in Delta Math are very similar to this. They're not word problems, but the triangles are going to be set up similar to this. So I noticed that I have across from my right angle, I have the hypotenuse. And across from the reference angle here, I have the opposite. So I have opposite and hypotenuse. So that is part of SOHCAHTOA, which means I have the sine. So very much like Ms. Rondeau did, I'm doing the sine of 48 equals x. And I picked the x. You can pick whatever variable you like. I don't recommend i's or e's, but everything else is fair game. Over 300. And then I don't do the love thing. So I just am going to multiply both sides by 300. All right. And we've got 300 times the sine of 48 equals x. Okay. And I do happen to have the answer because I know we are kind of running short on time. We want to show a couple of these. I know that when I put that in my calculator in Desmos, wherever I put it, I get 222.943, and we are in feet. So you always want, whenever you have a word problem, you want to put a label on the measurement. 222 is the number. That was my old classroom number when I taught at West Valley.
Yes, I also say if you don't put a measurement on it, then you must be talking about chickens. That's my favorite thing. So
nice. I prefer talking about chocolate. That would be good to talk about cookies too. I'm kind of hungry right now, so. Although I don't think 222 cookies would do good for my waistline.
No.
All right, I'm going to try to move to example 25, just so you guys see a couple of these different examples, because it's all about finding that right triangle and getting that set up. So from a point on the ground 28 feet from the base of a flagpole, the angle of elevation to the top of the flagpole is 63 degrees. Estimate the height of the flagpole. So I know I need a flagpole. Okay. I need to pick a point. I'm choosing my point over here. I know that my point is on the base of the flagpole. The base is always at the bottom, is 28 feet. The angle of elevation to the top, so my angle going up, is 63 degrees. We are supposed to estimate the height of my flagpole. I'm going to choose that as x. I am now going to figure out what I have. Oh, I noticed my right angle is right in here. Okay. I'm going to figure out what I have. So across from my reference angle is the opposite. Next to my reference angle, I know, is the adjacent. This time, notice the hypotenuse isn't there. You can label it, but if I just say opposite and adjacent, I know I'm looking at my SOHCAHTOA as TOA. So I know I'm just looking for tangent. Did you have a comment, Ms. Rondeau?
Oh, no, we assume the flagpole is straight up and down, which is why it's a right angle. We make a lot of assumptions, but yes. Good.
Sorry, I'm closing the door. We had the door to the outside open, and I saw bees, so I thought that was a good idea to close the door. We don't have a screen on that one.
No worries.
All right, so we've got 63 equals my opposite, which is x, over my adjacent, which is 28. Now, we've gotten really lucky on these, where these are just a multiplication over. It could be just like the ones Ms. Rondeau showed, where you might have to eventually do a division. So I'm going to multiply both sides by 28. So we've got 28 times the tangent of 63 equals x. I don't know. Does anybody put an answer in the chat? Are they working ahead?
No.
No, not yet.
No.
Okay. All right. I see it. I'm just looking ahead. Okay. Anything yet?
Nope.
Okay. Well, I'm going to keep
54.
moving.
Wait, we have an answer. 54.93 from, I'm not sure how to say it, Sach?
Sach, yes.
And
right,
Dima
so
also says 54.953 feet.
953 feet. I agree. That's awesome. Thank you guys for doing that. All right, so we're good on that one. Any questions so far?
Nope, just some encouraging comments from the group to the other students. Awesome. Good job, guys.
Okay, I am going to definitely get through at least 26 here. So before we end class, because I think that 27 is very similar to 24 and 25. So we're looking, this time it's an angle of depression. So we want to make sure you've at least seen one of these. So a boat is in the water, and you know I love boats. These are my boats. Okay, and we definitely need some water. Oh, I can make sparkly water. Here we go, sparkly water. See how cool the new toy is, Miss Rondo? All right. And then the water is 20 yards below a cliff. All right, so I need a cliff. There's my cliff. And it's 20 yards below. So that means my yards would be this height of my cliff. And then the angle of depression from the cliff to the boat is 37. So I'm going to go ahead and draw, and I'm going to assume my boat is kind of at my water line, or my angle is at my water line. We can kind of take some leeway with the where the positions are a little bit. We wouldn't be off by a whole lot, but if we were doing this in real life, we would want to make sure we knew whether we were measuring from the top of the boat or the water line.
37 degrees. Did you say 37 degrees?
37 degrees.
That's
So,
my favorite number.
oh my goodness. Mine's the square root of 98. Don't ask me what. All right, so 37 degrees. Remember, our angle of depression has to come down from a parallel. And then this is the Mrs. Ballard kind of shortcut. We know that these are alternate interior angles from geometry. Oh boy.
We lost the water.
I lost the water there. Oh, that water wasn't as good. Sorry, I hit a button that I'm not as used to. All right, so we've got 37 degrees. So we know that those two are both 37 degrees. So I have, let's see, I know I have a right angle there. I know I have my opposite. And I need to know what I'm looking for, because I haven't figured that out yet. So if the angle of depression from the cliff is 37 degrees, how far is the boat from the cliff? So it looks like, ooh, I need this measurement right here. The water is what I'm really looking for. So water happens to be next to my reference angle. So I have opposite and adjacent again, which means that I have the tangent of 37. So I'm going to go ahead and write that out. I've got tangent of 37 equals 20, the opposite over the adjacent x. All right. I don't do the love connection. Okay. But I'm going to just show you actually two tricks. Okay. So first way, I would do the same boring thing, because I'm boring, that Mrs. Rondeau would do. And actually, no, I'm not going to show you two. I take that back. I'm just going to show it this way. I was thinking of something else that I do in calculus, but we're not going to do it that way. All right, so we're just going to go x times tangent of 37 equals 20. And then I know that this is just an ugly decimal point number that I haven't written as a decimal yet. And I'm going to divide by that ugly decimal point number. All right. And then do we have any, and I really should have written an approximately on that last one too. Do we have any suggestions as to what that is in the chat?
Not yet. Were you going to show them the switch move?
The switch. I was going to try to do the flip, but then the 37 would be on the tangent would be in the bottom, and that probably wasn't a good idea. So,
okay. So we have some answers. 26.541 from Genesis, Dima 26.541, and then Ariana 26.541 yards.
awesome. Good. Oh, I like the yards. That's even better. Good job.
Nice job all around, though.
One quick note, which is something that I should have done really on all of these. Technically, when we go to a decimal, it is an approximation. Okay, so I really should have written this as an approximation because it isn't technically equal. And if you didn't do that, we wouldn't mark it wrong. But as we start moving to calculus, and this is something I'm learning more and more about right now, they can give us points down as a linkage error. So because we're writing something that's equivalent versus an approximation. So it's not a bad idea to, if you're writing it in decimal, write those little approximately symbols. Okay. All right. I think that's it for the day, Mrs. Rondo, because we're going to skip number 27 since they've been so good and awesome today.
So I would just echo what Mrs. Ballard said about the approximation. Technically, even on the problems that when we went back and the ones that I did with you guys with the trig functions, those as well, once you've rounded it, that's an approximation. It should be using the approximation. Just a comment.
Yep. And I'm sorry I didn't catch that sooner. I just thought of it just now. So
no worries.
I watched a whole thing this morning about errors on the AP test. So it's fresh in the mind.
Yeah.
All right. It looks like we've lost some people. We were at 27 and we're down to 22.
Other people have other classes.
Oh, okay. All right. Well, you guys, what?
I said the nerve.
Apparently, I thought we were entertaining enough to keep them the whole time. All right. So if you guys don't have any other further questions, remember that we are looking at tomorrow. So tomorrow, same time, same place. And there is an assignment out there posted. I know I posted mine. I think Miss Rondo will post hers. And it's still Delta Math, and it covers a lot of what has been put in here. Okay? So we will see you guys tomorrow. All right? Have a good day.
We love you, but leave quickly.